So homework 25 starts off identifying functions from relations. And a relation is just a fancy name for a set of ordered pairs, which sometimes they wrote ordered pairs and sometimes they wrote it with a drawing. Decide whether it's a function or not. In order to be a function, each value in the domain, or the x values, can only have one corresponding value in the range. So if I was to write this as ordered pairs on this first one, after I get the right pen, the desk goes to -8. The paper goes to -8. The sun goes to -8. And the rock goes to -8. For each one of these things, you only have one value here that is going to be a function. It doesn't matter that it's all the same value, but each one only goes to one answer, basically. So that is a function. As opposed to this one, the cloud goes to 5, but the cloud also goes to, what is that number there? Is that a 6? It's hard to read on my screen. Oh, it's a D and an S, isn't it? See, you can't read them. S and D. I really don't need to go any farther than that, because for this value in the domain, I've got two different values in my range. It is not a function. So if I have a list of ordered pairs, if all of my x values are different, I know it's going to be a function right away, because they're only going to have one y value. If any of my x values repeat and the y values are different, then it's not a function. So here, I've got -3 going to -3, -3 also going to -4, -3 going to 9, not a function because the -3 goes to more than one value in my range. Here I've got k going to k, b going to g, g going to k, but then g goes to g. So again, the g goes to two different values, not going to be a function. So for each value in my domain, I can only have one corresponding value in my range in order to be a function. So if I look at number 2 on the first one, is that a function or not? It is not a function. The rock goes to two different things, right? Goes here, not a function. How about the second one? Yes, that is a function. Each one of these only go to one thing. They each go to them. The third one, yes, that is a function. You can tell quickly because all of my x values are different. So if all my x values are different, I know it's going to be a function. And on number 4, is that a function? Yes, it is. Again, all of my x values are different, so I can tell quickly, yep, that is a function. And number 3, on relation 1, is that a function? Nope, the 4 goes to a whole bunch of different things. Not a function. Number 2. Nope, the -1 goes to both -1 and 4, so that's not a function. Number 3. Yes, it is. The k goes to one thing, the r goes to one thing, the n goes to one thing, and the x goes to one thing. It is a function. And number 4. Yes, that is also a function. Each of those only go to one thing. So, number 4 is still asking for each graph, is it a function or not? So, for each value in my domain, for each x value, I can only have one corresponding y value. Since the line x equals some number is a vertical line, they tell you to do the vertical line test. If any vertical line touches more than one point on your graph, it is not a function. So if I drew my vertical line, it only touches one point on my graph. That means for whatever this value of x is, I have my one value of y. It is a function. Same thing here. If I drew my line here, it only touches once. Over here, it only touches once. Anywhere I draw it, it's only going to touch the line one or none time, at most once. If I look at the next graph, if I drew my line there, once, every line I can draw, I only touch once, yes, that is going to be a function. However, on the next one, if I draw my vertical line, I'm touching my graph here and here. I'm going to have two y values for that x value. That is not going to be a function. And of course, they give you a ton of these, and then I have to figure out where I'm at. So the last two there on that question, is this one a function? No, because if I drew my line right here, I'm going to touch all three of these points. Definitely not a function. How about the last one on that question? Is that a function? Gavin's shaking his head no. If I drew my line right there, I touch it twice, not a function. I get them all in there on number 5. If I smush it that way, whoops, that's number 4. Helps if I get on number 5. Maybe. So, first one on number 5, is that a function? Yes, if I draw my line, only touches once. The second one, nope, if I draw my line here, if I can draw my line, it hits twice. The third one, that one looks okay, nothing's overlapping if I draw a vertical line. The fourth one, no, if I draw my line, I hit it twice. The next one, no, if I drew my line here, I'd hit that twice. I'm going to move this one up because I can't quite see the last one. So on the last one, is that one a function? Yes, it is. If both of these dots were solid dots, then it would be no, but since that top one's open, when I draw my line, technically, if I could draw my line, I'm only touching the bottom, not the top. And so since that one's open and that one's closed, I'm only touching once. So yes, it is a function. Doesn't overlap anywhere else. And then number 6. The first one on number 6, is that a function? Nope. If I drew my line, I touch it twice. The second one on number 6? Nope. If I drew my line there, I touch it twice. The circle? Nope. If I draw my line, I touch it twice. The fourth one? That one looks okay. Nothing's overlapping. Yes, that one's good. The fifth one on number 6. Nope. And my parabola going that way is good. Yes. Seven, 8, and 9, evaluating functions. So we have functions written in functional notation. F of x is equal to negative 2x cubed minus 5. G of x is equal to negative 3x minus 1. When it tells me to find f of negative 2, I'm looking in the f function and basically just substituting the negative 2 on the right-hand side and finding my number answer. So I'm going to take negative 2 times negative 2 cubed minus 5. If I follow my order of operations, I have to do the cubing before I do the multiplying. So negative 2 cubed is negative 8. Negative 8 times negative 2, positive 16. 16 minus 5 then gives me a value of 11 for f of negative 2. If I'm doing g of 3, tells me I'm going to put a 3 into the g function, so I'm going to take negative 3 times 3 minus 1. Negative 3 times 3 is negative 9. Negative 9 minus 1 is negative 10. And so for g of 3, I get an answer of negative 10. So number 8, we want to start up and find f of negative 3. So in my f function, I'm going to put a negative 3 in for the x's, and I happen to have a couple spots here. So I have to take 3 times negative 3 squared minus 3 times negative 3. So, negative 3 squared is 9 times the 3 in front, 27. Here, negative 3 times negative 3, plus 9, and 27 plus 9 is 36. So f of negative 3 is going to be 36. G of negative 6. So I'm going to take 2 times negative 6 minus 1. I would get negative 13. Negative 12 minus 1 is negative 13. So number 9, f of negative 2. So 3 times negative 2 cubed plus 5. So negative 2 cubed would be negative 8. Negative 8 times 3 is negative 24, and negative 24 plus 5 would give me negative 19. So f of negative 2 would be negative 19. G of 5, negative 4 times 5 plus 4 would give me negative 16. Negative 20 plus 4 is negative 16. So those were the easier ones. Then they go to the harder ones. So number 10, I'm going to find f of 7. So I'm going to put 7 in for my x. 4 plus the square root of 7 minus 2. If I do 7 minus 2, I get the square root of 5. In this case, I can't simplify the square root of 5, so there's nothing more I can do to simplify that. So 4 plus the square root of 5 is just going to be my answer. If I could simplify it, I would keep going, but I can't, so I won't. Then I'm going to do g of negative 3. So I'm going to do negative 3 squared plus 1 on top, and then negative 3 plus 1 on the bottom. So when I simplify that, I would get what on top? 10, and on the bottom, negative 2, and 10 over negative 2 reduces down, so negative 5 would be my answer in simplified form. And then we're going to do h of 2/3, so we're going to do the absolute value of negative 12 plus 9 times 2/3. I'm going to simplify inside my parentheses first, following my order of operations. So I'm going to do the 9 times 2/3. 9 times 2/3 would give me 6. 3 goes into 9. 3 times 2 is 6. So then I have negative 12 plus 6. And a negative 12 plus 6 is negative 6. And then I'm going to do the absolute value of negative 6. And the absolute value of negative 6 is positive 6. And so 6 would be my answer in simplified form. So number 11 says we're going to start out with f of negative 3/4. So we're doing the absolute value of 16 times negative 3/4, and then we're going to minus 17 from that answer. So 16 times negative 3/4 would be negative 12. The absolute value of negative 12 would be 12, and then 12 minus 17 would give us an answer of negative 5. Simplified as we can get it. g function. We're going to do g of -5. So we're going to have -5 on top. Then we're going to do -5 minus a -5 squared, right? Following my order of operations, I'd want to square that -5 first. So -5 squared would be 25. It has the minus sign in front, so now I have -5 minus 25 on the bottom. So I get -5 over -30. And then if I reduce that fraction down, I would get 1/6. Negative over a negative makes it a positive. And then we want to do h of 4. So we're going to do the square root of 2 times 4 plus 2. So 2 times 4, 8 plus 2, 10. We get the square root of 10. Can I simplify the square root of 10? Nope. That's just going to be my answer then. Number 12, we are going to do f of 2 starting with. So 4 plus the square root of 2 minus 2. If I simplify that, I get that's 0. So 4 plus 0 is 4, right? G function. We are going to do the absolute value of 3/2. How about I write the halves instead of the 6 first? 3/2 times 6 minus 10. So 3/2 times 6 would give me 9. 9 minus 10. My board quit writing. 9 minus 10 is -1, and the absolute value of -1 is 1. And h of -2. -2 on top, -2 squared minus 10 on the bottom. So we're going to have -2 on top, and on the bottom we would get -6. 4 minus 10 is -6, which reduces down to positive 1/3 then. And 13, 14, 15, we're still doing functional notation, but now they throw variables in there so that you can't simplify it into a number answer, just to make sure you understand the concept. So we are going to replace any of our x's with 2n. So we're going to do 2 times 2n squared plus 4 times 2n, and then we're going to simplify that as much as possible. So we got to do the squaring first. If I take 2n times 2n, that would be 4n squared. Then I'm going to multiply it by the 2 that's in front. So I get 8n squared there for my first term. My second term, I'm just taking 4 times 2n, which is 8n. These are not like terms. I can't add them together, so my answer is just 8n squared plus 8n. So number 14, this time I'm going to substitute z plus 5 in for my x's. So on the top of the fraction, I'm going to have z plus 5 plus 7. On the bottom, I'm going to take 3 times z plus 5 plus 2. So on the top of my fraction, I'm going to get z plus 12. On the bottom of my fraction, using my distributive property first, 3z plus 15 plus 2, which is 3z plus 17. I can't simplify that fraction unless I can factor out a common factor. I can't factor either the top or the bottom, and so z plus 12 over 3z plus 17 will just be my answer. Number 15, they want you to put a negative x in for the x. So I'm going to have a negative x squared minus 1. And when I square my negative x, I get x squared. So I just get x squared minus 1. I can't do anything else to simplify that. That's just going to be my answer. And 16, 17, and 18, wanting you to know what domain and range are. The domain is just the fancy name for what the x's are. The range is the fancy name for what the y's are. Wants you to put your answer in set notation, so you do have to put the set symbols around your values. And if something occurs more than once in the set, you don't need it in your list more than once. So my domain would be 9, 0, and negative 7. I don't need to put that negative 7 in there more than once. And I don't have to put them in order unless I really want to. My range would be the negative 8, 9, 4, and negative 5. Nothing repeated, so I just listed each of my y values. So on number 17, if I'm going to list my domain, I've got to put my set symbols. And so my domain would be negative 5 and 9. And my range, negative 5, 9, and negative 3. And the last one, my domain would be 7, negative 2, and 0. And my range, listing my y values, I would have 6, 4, negative 9, and negative 2. So just wanting you to recognize what the word domain means and the word range means. Domain your x's, range your y's.